we have done Narnia 3. Now we have to log into Narnia 4. So this is the password, clear. So now our point of interest is these two files. Okay, since we're in Narnia 4, we have to care about Narnia 4.c and Narnia 4. Okay, so let's see what Narnia 4 has for us. Okay, it's returning nothing. Okay, so we don't know what we can give, right? So let's see the file Narnia 4.c. Okay, so we have some headers and we have this statement, and then there's a main function. Okay, and in that main function it accepts some argument and then a variable I initialized as integer and some buffer variable with 256 bytes of data is initialized as character. Okay, cool. And then there's a for loop. It says for I equals to 0, environ of I not equals to null, then I plus plus. So we'll see what this environ is. Okay, so if this is the condition, then memset, which means they're setting inside the memory of this environment variable to null character. Okay, which they are saying essentially to make it as a 0 or null. And how long this null character should exist? As long as the string length of this environment variable. Okay, so the whole value of each environment variable is set to null. Okay, so the last environment variable is already set to null. So once this reaches to the end of this list of environment variables, then it detects that it is null, so then it stops executing and then it goes to the next statement. Okay, in the next statement it's going to check if there are any arguments that exist, and the value of argument will be stored inside this buffer. Okay, so previously we have given this argument, right? So this argument will be stored inside this buffer variable. So that is what this string copy does. Okay, this is where the vulnerability is. They are not restricting any limitation on how much buffer variable should contain. Okay, so it doesn't matter how big this is, it can still accommodate into this buffer. Okay, but this buffer variable can only store 256 characters. Whatever is excess will go into next point of the stack, okay, which is I in this case. And then even if this one fills out, it has to go to some other area where it can return some return address. So we need to find that address and point that return address to a shell code. Then we can execute that shell code and we can get a shell. Okay, so let's see what this environ is, and then we'll go to GDB. Okay, so we have a manual page for environ and we'll see what it is. The name is environ, it is user environment. This is how it should be implemented, and this is the description. So the variable environ points to an array of pointers to strings called environment. Basically this environ will point to all the environment variables. Okay, so the last pointer in this array has the value of null. Okay, just as we discussed, the last pointer has to be null, and then the for loop exits from there, and then next statement will continue. Okay, so let's get back to the code. So you need to understand that if we can change all the environment variables to null, then we cannot execute anything regarding environment variables, right? But that's not the case with this. So they have deliberately made this for loop because previously in Narnia 1 we have changed the environment variable and we pointed it to a shell code, right? This time we cannot do that, so we have to do something else here. And also this environmental variable is set to null only to this particular shell. Okay, only to Narnia 4. So after some time some cron job should be running so that all the environment variables should be set to its previous states. Okay, so everything's good. So now let's open GDB and try to overflow this buffer and let's see what happens. So GDB Narnia 4 and yes. So the first thing we usually did was disassembling the main, but this time let's try to do without disassembling main to see what happens. Okay, we know that there's Python 3 that exists, so we'll use that to write a Python script and print lot of strings. Okay, since it is 256, let's give under 256 and then see what happens. Okay, so let's hit enter. Okay, so it exited normally. Okay, there's no buffer overflow that happened. So let's increase this value to 260. Okay, so let's see what happened. Okay, it still exited normally. Okay, so let's make it 270. Okay, so now we have some segmentation fault. Where is the segmentation fault is even pointing to? It's pointing to this A again. So this is the return address. This is usually called EIP. In assembly language, EIP is called as extended instruction pointer. Okay, so basically it just points to a different address that's called return address. Okay, so we have to see if we can override this return address and point to something else. Okay, so let's see that since we can overflow this, so let's try to change this value a little bit to understand where it actually exists. In addition to this, let's give some 4 A's, B, and let's change this value to 60 again. So yes, we still got a segmentation fault, but it did not show any return address. So EIP is not been overwritten. Okay, so we'll just increase some payload. So we'll say 262. So let's see what happens. We have a return address and we can see that 4242 exist over here. We'll just have to give 2 more B's, or we'll just have to give 2 more A's so that this B's will be filled. Okay, so let's do that. So it's 264 now. So start from the beginning, and as you can see, all the 4 B's fit exactly to the EIP pointer. Okay, basically return address. So we can overwrite this return address with this number of bytes of data. We'll just inspect the memory stack and see where this actually happens. Okay, so since this is 250 or 260, so we'll just give 260 words of memory. Okay, so x 260 and words x from stack pointer. Okay, so this is examine and this is the number of words of memory to examine, and then this is to show it in hexadecimal format. Okay, and this is the ESP pointer. Okay, stack pointer. So we'll see what happens. So next. Okay, as you can see, this is where it starts and this is where it seems to be ending, and rest of the environment variables, as you can see, it is set to 0, right? So we'll just replace all of this with nops, which basically is no operation, and then at the end of this payload we have to give shell code so that the shell code will execute. Okay, and at the end we also have to give the return address somewhere in the middle here so that it will just slide down and execute the shell code. So let's do that. And you need to also remember that we cannot directly keep hexadecimal code something like this using Python. Okay, so let me show you what I mean. So let's hit enter and start from the beginning, and then you go to the stack pointer, and as you can see, we don't see just 90. Okay, we also see C2, okay, which is something else. So instead of using this Python, we have to use something like echo or printf. Okay, so when we use something like printf or echo, we have to give all of the payload instead of giving it as a multiplication of payload. Okay, we have been using this shell code, and this shell code is actually /bin/sh. Okay, and it's only 23 bytes. So let's use this shell code and see if it actually works. Okay, if it doesn't work, we have to go with some other one. So since this challenge actually requires effective user ID to be executed, I'm thinking this will not work. Okay, but let's try it anyway. So this is a shell code. Just remove this, and here we got our shell code. Okay, and since this is 23 bytes, so we have to subtract that from 264 because we already have 264 bytes of data. 23, that would give you 241. Okay, so multiply this 241 with 4 and you get 964. Okay, So this character count should be like 964. Let's see. Okay, it's too much. So let's remove some of it. So we got our 964 payload. Okay, so let's copy this and paste it right before this. This is our payload right now. Okay, and at the end of the payload, you need to give some return address. Okay, so let's go back. This is the output that we got previously. Okay, so somewhere in the middle, if you just keep the return address somewhere around here, then it will just slide down and it will execute the shell code. Okay, so let's take this address and write it at the end of the shell code. Okay, we have to write it in little endian format. So \x c0 \x d4 \x ff \x ff. Okay, so this is our final payload. Let's just input something like printf or echo e. So let's say echo e, and then this will execute, and we have to run it as a shell script. So we have to say that this is a shell script by keeping a backtick at the end. Okay, so let's copy this, let's run it and paste it, and let's run it and run from the beginning, and let's continue. Look what we got here. We got a shell, right? So, and just like we imagined, this return address went somewhere in the middle and then just slide down because it is no operation. It will not do anything over here. And then it came to the shell code and the shell code executed. Okay. So let's do the same thing outside GDB. Let's say Narnia 4 and then this, and then hit enter, and we got a segmentation fault. So we have checked that. So this particular shell code is working inside GDB but not outside GDB. Okay. So let's go with some other shell code which also have this effective user ID being preserved. Okay, that is 606. So let's use this shell code and create a payload. Okay. Okay, we have created this payload, and this payload has these many characters plus the shell code. Okay, and then a return address. Okay, so this return address we can get it from the GDB. Okay, so it's around D5. Okay, D5, let's say some other thing like 50 or something. Okay, so we've already seen that in GDB. So let's get the shell code and let's try this in GDB, and then we'll try it outside GDB. Okay, so Narnia 4, and then yes, and then run the shell code, and then yes, and we got a shell. Okay, so let's exit out of here and use the same shell code outside GDB. Okay, so exit Narnia 4 and then the shell code. If you hit enter, and we got a shell. Okay, so if you type who am I, you get Narnia 5. Okay, so let's get the password /etc /Narnia_pass Narnia 5. Okay, so make sure that if one shell doesn't work, try with some other shell. Okay, as I said previously, either you need to take care of this shell code or you need to take care of this return address. Okay, so rest of the things won't be changing that much. Okay, I hope you get it, and I'll see you guys in the next one.